Hi, this is Ron Cipcic, and in this particular episode, what we're going to do is we're going to take a look at something called the consumption function. So let me go ahead and move it up here. And the consumption function looks at the relationship between disposable income and consumption. So the number one factor that affects the level of consumption in the economy is the level of disposable income. We abbreviate disposable income with a Y. Now remember what disposable income is. It is income after taxes. So if you take personal income and subtract out personal taxes, things like personal income taxes and the Social Security contribution and that sort of thing, you get disposable income. Y stands for disposable income. Let me just make a little side note over here. Y stands for disposable income, or what we call after-tax income. Okay? And when disposable income increases, that will motivate a member of a household or a household to spend more. So C stands for consumption. Now this not only applies to an individual, it applies to a nation. If a nation's disposable income increases, we would expect that its consumption increases. So the level of disposable income is a very, very important factor when we're trying to assess the level of consumption, how much households are spending. If the level of disposable income decreases, if that should happen, we would expect that that would decrease the level of consumption. So again, there are factors besides income that affects consumption, and I'll be looking at some of those a little bit later in the lesson. But the number one factor that affects the level of consumption is the level of disposable income. Y here is called the independent variable. It's the independent variable. It's the cause. And C in this relationship is what we call the dependent variable. Dependent variable, it is the effect. Okay? Now let's go ahead and let's tie this into a two-dimensional graph. So I've gone ahead and I've plotted a two-dimensional graph, and what I have put on the y-axis is consumption, because normally we put the dependent variable on the y, or the vertical axis, and I've put disposable income on the x-axis, and that again is the independent variable. Alright, so the x-axis is called y here, disposable income, and the y-axis is called C, which is consumption. Now, if we take a look, let me go ahead and change my colors here. If we let me just go ahead and turn this into green. If we pick a coordinate on this function, by the way, is called the consumption function. And the consumption function shows the relationship between C and Y. We would expect that function to be what? Upward sloping Y, because as Y goes up, C goes up. As Y goes down, C goes down. So let's just go ahead and prove that. So we're going to pick a point on this consumption function. Let's actually use symbols here. This is Y1, and then let's read the C value. This is C1, and we'll call this point 1. And then we'll pick a point up here, call this point 2, read down. Call this Y2, and then we want to read across. Call this C2. So what does our graph show? Our graph shows that as Y increases, this could be for an individual or for a nation, C increases. Now what we're going to see is this is not dollar for dollar. We'll see here in just a minute that a dollar increase in Y actually leads to less than a dollar increase in C. In other words, some of the additional disposable income is saved. We'll talk about that in a minute. But right now, let's go ahead and let's talk about some of the properties of this thing called a consumption function. Okay, first property is we see that it's upward sloping. That's one property. We also see that it has what is called a positive y-intercept. This y-intercept, remember this is the vertical axis, this is called the y-axis in algebra. This vertical axis is called consumption in this application, but this point right here actually is called the y-intercept, and this will be labeled little a in our model, and I'll be explaining little a in just a minute. Okay? Now, let's go ahead and let's put some numbers on here and actually mess around with this. So let me go to a different color, and let's make this 1,000, and let's make this 1,100. You go, well, how can C be greater than Y? It can be. It could be that a household can consume more than it earns in income in a year by borrowing, or not just borrowing from some other party, but we could borrow from ourselves. In other words, we could take money out of savings. So our consumption in a period could be greater than our income in that period. Okay, and let's say that at Y2, income has jumped up to 2,000, but consumption has jumped only up to, let's say 1,900. So what we see at this higher income level, we've doubled the income level, we see that consumption has not increased dollar for dollar. So the increase in disposable income is 1,000. This has increased 1,000, but the increase in C is only 800. Okay, and that's going to be an important idea here in just a minute. Okay, now if you have 2 points, on a line, you can always find a third point. That's a basic algebraic principle, that if I have 2 points on a line, I can always find a third point. A is actually a point on the line. Even though it is the y-intercept, it is a point on the line. Now let's scroll up, and I want to just do a very brief little algebra lesson with you, and then we'll come back and we'll actually solve for A. We can actually find A. But let me just remind you of a couple things. Okay, I'm going to just sketch a quick little two-dimensional graph here, and it looks like I'm using blue, which is fine. And I'll put this in here, and then I'm going to call this the y-axis, I'm going to call this the x-axis, and this is called B. The y-intercept in algebra is generally called B. The slope of this line, remember what the slope is? x1, x2, y1, y2. So the slope of a line is what? The slope of a line is its what? Is its rise over its run. Well, we can take the slope here. Now remember what we do. We call slope, usually in most algebra classes, you'll call slope m. What does m equal? M equals the change in y, the rise, over the change in x, which is the run. But remember what that is. That's going to be equal to y2 minus y1. That's the rise. The difference is the distance over x2 minus x1, which is the run. Okay, so m is the slope. Now we can actually write a formula for this line. This is an upward sloping line, but the y-intercept formula is y equals mx plus b. And again, let's review our algebra here. M is the what? M is the slope. What's b? B is the y-intercept. That's I-N-T-E-R-C-E-P-T. Sorry about that. And then, of course, x is our what? X is our independent variable, and y is our dependent variable. Okay? So this ought to be familiar to you. You've had algebra before, hopefully. You really shouldn't be studying college-level economics if you haven't had a little bit of algebra in your past, and so we assume you've had that. Now let's go back up to our picture up here, and we can actually write a formula for this line which will allow us to do some interesting things here. So let me go to a different color here. Let me go to red, and this is not the y-axis and this is not the x-axis. This is the c-axis and this is the capital Y-axis. So actually what we have here is we have this formula. We have c equals MPC, and I'll prove that that's the slope, times y plus little a. So c is the y variable. Y, capital Y, down here is the x variable. MPC, which I haven't defined yet, is what we would call the slope. And A is the what? Is the y-intercept. Okay? So here's, this is consumption, this is disposable income, this is MPC, which I haven't defined yet, and this is A. Okay? All right, now let's go ahead and solve for A. We can actually solve for A. You go, how can we do that? Well, we have the slope here. We have the slope. We have MPC. So let's go ahead. I'm going to move down and we'll actually calculate this. What is the slope of this line? What is the slope of this line? Well, the slope of this line equals MPC. Slope of this line equals MPC. Now I haven't defined MPC yet, but just go ahead with that. And that's what? The rise of the line plus 800 over the run along the line 1,000. Remember? So let me just scroll back up and show you this. If you move from point 1 to point 2, C increases by 800, that's the rise. Y increases by 1,000, that's the run. So this is plus 800 over plus 1,000. So what's the slope? The slope is equal to 0.80. 0.8. Actually, if you reduce this fraction, it would reduce down to 4/5, and if you divided 4 by 5, you get 0.8. All right, so now we have the slope. Now let's go ahead and scroll back up. I think we have a little bit of room up here we can use. So let's pick a coordinate. Let's pick a coordinate on the line. It doesn't matter which coordinate we use. Both coordinate 1 and coordinate 2 are actually coordinates on this line, so it doesn't matter which one we pick. So I'm just going to pick the first one. So I'm going to plug it into this equation. So 1100 equals 0.8 MPC times what? Well, when C is 1100, what is Y? Y is what? Y is 1,000 plus what? Plus A. So here's our formula. 1100 equals 0.8 times 1,000 plus A. I took the C value, 1100, plugged in the slope, 0.8, plugged in the corresponding Y variable, 1,000, and I'm solving for A. Well, now I have an equation here. So this is what? This is 1100 equals 800 plus A. Can rearrange here. A equals 300. So if I have 2 points on a consumption function, I can find a third point. In this case, A is what? A is 300. Now, what is A? Let's just talk about A for a second. Let me go ahead and scroll down. I'm going to need to find a little bit more room here, and I can talk about what A actually is. I said up here that A actually equals 300, but what does that mean? What's the idea there? Well, A is what we call autonomous consumption. And what this is this is consumption. Let me write it out here. This is consumption that is what? That is unrelated to income, which is Y. So in other words, what we're saying is some income is unrelated to the level of income. We're saying that some consumption is related to the level of income, but we're also saying some consumption is not related to the level of income. You go, I can't really understand what you're saying, Mr. Cipcic. Well, let's go back up to our graph. Look. When the level of income is 0, this point says there's still some consumption. Now look, the level of income is never going to be 0. But what this suggests is some consumption, this level of consumption right here, has nothing to do with Y. It's determined by factors other than Y. So this is determined by what we would call non-Y factors. Non-Y factors. Factors other than Y. That's determined by non-Y factors. For instance, confidence could be a factor. Consumer confidence may affect consumption. A person's wealth. Wealth is not income. A person can have income and have no wealth. All right? So there's lots of factors that could actually impact the household consumer. The primary factor is disposable income, but there are other factors that also affect consumption, and those factors are autonomous factors. And I'll be talking more about those in a minute. Think about it. If you worked 3 years and saved each of those 3 years, could you actually consume in year 4 even though you earn no income in year 4? Say that you work 3 years and then you decide to travel in year 4. Well, you could actually consume food and shelter and that sort of thing in year 4 even though you show no income in year 4. Why? Because you've saved up in previous years, you've accumulated something called wealth, and now you're living off your wealth, you're not living off your current income. Income, remember, is a flow. It's what I'm earning this year. Wealth is a stock. It's what I've accumulated over multiple periods. All right? So that's important to keep in mind. All right, so let's go ahead and just summarize this a little bit, and then I'm going to add another factor to this. So what causes movement along the consumption function? Well, it's a change in income. So changes in income cause movement along the consumption function, and they produce increases in consumption. Okay, now I want to explain why is the slope of this line called MPC. Let's take a look at that idea and make sure we understand that. So we've talked about A, we talked about the slope, but we've called the slope of the consumption function MPC. Why? I've got to go to a different color here. This red is just a little too bright for me. So the slope of CF equals something called MPC. And MPC, as we said, is the change in C over the change in Y. What do we mean by MPC? What is this? MPC is what is called the marginal propensity to consume. What is that? That's the percentage of additional income, Y, that is what? That is spent. So remember what we said, MPC because it's equal to the slope, is equal to the change in c over the change in y. So in our example, when we increased income by 1,000, consumption increased by 800. So the increase in consumption, the change in c, was 800, when the change in y was what? Plus 1,000. Well, what is that? That's 0.8, which is 80%. So what we're basically saying is, if the MPC is 0.8 or 80%, 80% of additional income, 80% of additional income is spent, which implies what? 20% of additional income is saved. All right, so let me go ahead and go down here and I'll summarize this. So we said earlier that the slope of CF equals the change in C rise over the change in Y. We said that. Now we've said that MPC, the marginal propensity to consume, equals what? The change in C over the change in Y. Well, if slope of CF equals change in C over change in Y, and MPC equals change in C over change in Y, what can we conclude? Therefore, the slope of CF equals what? Equals MPC. So let's go back up to our picture and we'll see this. And I'll explain this to you on the picture. Sorry, got this crazy scrolling system here. Every time you add a dollar here, every time you add a dollar on this axis, 1, 1, 1, 1, 1, what are we adding on this axis? We're not adding a dollar, we're adding less than a dollar. What are we adding? We're adding 0.8, 0.8, 0.8, 0.8. So that's what slope is. Slope is what? Rise 0.8 over run 1. So every time you add a dollar to the horizontal axis, you're adding 80 cents to the vertical axis. All right, which means that's the slope. And that slope is called MPC. Now, a couple more ideas and we'll begin to circle the airplane, and we'll try to get this plane on the ground here in a few minutes. Whenever you hear a teacher or a preacher say they're about to end, beware. Public speakers like to say that, then they go on for another hour. So beware, or be square. All right, anyway, so MPC plus MPS must therefore equal 1. You go, what do you mean? Well, MPC is what? The marginal propensity to consume. It's the percentage of additional income that is what? That is spent. What is MPS? MPS must be the marginal propensity to save. Percentage of additional income that is saved. So if this is 0.8 and this is 1, and 0.8 plus something must equal 1, then that something must be what? 0.2. So what we're saying is, if income increases by $1, spending will increase by 80 cents, saving will increase by 0.2. So we could write it this way. We could say change in Y leads to two things. Well, let me just do it this way. Let me just generalize it. Change in Y leads to a change in C, but a change in Y also leads to a change in S, saving. So if Y goes up by $1, then C is going to go up by 80 cents, and saving is going to increase by 20 cents. And of course these two must add up and equal that. Okay? You can express MPC and MPS as percentages, and what that would look like is simply 80% plus, let's get rid of that, 80% plus 20% must equal what? 100%. Okay? Later on in our studies of macroeconomics, we'll rearrange this formula. We'll actually take MPC plus MPS equals 1, and we'll convert it into this formula. 1 minus MPC equals MPS. So you'll see later on that we need to find MPS. We can find it by remembering this formula. If we have the slope of the consumption function, MPC, we therefore have MPS. So if we know that this is 0.8, we know that this is what? 0.2. Okay? Now I'd like to share one more thing with you before we wrap up. I told you this ending might take a little longer than you thought. I just showed you what causes a movement along a consumption function. Let's talk briefly about what shifts a consumption function. So let me just set this up very quickly and go ahead and draw this with me. It's always good to draw the pictures with the teacher, because if you draw the pictures, you'll remember the pictures better. So this is C, this is Y, this is going to be called CF1. I'm going to choose a point on this consumption function, read down Y1, and I'm going to read the corresponding point. This is point 1, C1. All right? Now, let's assume that something other than income changes. In other words, let's hold income constant. Let's assume that there's an increase in consumer confidence. So say that consumers are feeling more confident about the future. When people feel more confident about their future, say they're more confident about their job situation, their income prospects, maybe they're just more comfortable with the political setting, maybe the person they love the most is president, and when that person is president they feel most comfortable and most optimistic about the future. Lots of factors affect confidence, but when people feel confident, guess what they tend to do? They tend to spend more. So everything else held constant, ceteris paribus, including income. Everything else held constant. When I'm feeling more confident, I'll spend more out of my current level of income. So this is little a1 down here. So how do I show this? How do I show this increase in confidence? Well, I can't move along the line because y hasn't, look at, whoa, y hasn't moved. Y hasn't moved. Y has stayed what? Y has stayed constant. What I have to do is I actually have to shift the entire line. I have to move the entire line up. You go, why? I have to show an increase, I have to show an increase in consumption that has nothing to do with income. So I have to shift the entire line upward. So what I need to do is I need to show the line shifting upward. Why? Because now I can show an increase in C. I can show an increase in C that has nothing to do with a change in Y. Y has stayed constant. Disposable income hasn't changed. Households are simply spending more out of their present level of income. What caused this? An increase in confidence. So if there's a shift in something other than income, confidence would be called a non-income income factor. Why non-income? Because it's not income. So confidence is something other than income that affects consumers. That's got to shift the consumption function. So let me just go ahead and write out a couple of factors that could do this. And truly, 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 promise, 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 we will be done with this lesson. So let me write this header out. Factors that shift the expenditure line, wrong line, consumption function. I'm getting ahead of myself here. Stay tuned. Factors that shift the consumption function upward. We'll do upward. I assume you can reason this through and do the opposite. Okay, so one factor would be an increase in confidence. If consumers feel more confident, all things held constant, they tend to what? They tend to spend more. Another factor, increase in wealth. Wealth, again, is not income. Very, very important idea. I have funds in a retirement fund. The value of that retirement fund is not my income. I have saved for over 25 years. I have funds in this retirement fund, and that does not equal my income. My income is the amount I'm paid for my services in this year. My wealth is funds that I've accumulated over a number of years. Now, let's say that I have those funds in the stock market, and the stock market is advancing. Stock values are increasing, and I feel wealthier because my retirement fund is rising. Well, if I feel wealthier, what do I tend to do out of present income? I tend to spend more. A good example would be to flip it. What if stock values crash? Well, that doesn't mean that the college that has hired me is going to stop paying me. But if my retirement fund were to be cut in half in terms of its value, I would feel a lot poorer, and I probably would spend less out of my present income. So we're assuming here that income is being held constant. We're looking at factors other than income that can either expand consumption or, if you flip the arrows around, depress consumption. The third factor would be interest rates. A drop in interest rates, talking here about the real interest rate, the inflation-adjusted interest rate, but a drop in interest rates might motivate me to spend more. So if interest rates are very low and car dealerships are offering very low interest rates, the lowest interest rate they might offer would be 0. In other words, they're offering me a same as cash financing option where I can buy the car, let's say, over 6 years, 5 years, 4 years, and I basically pay no interest on it. That's going to probably motivate me to want to buy a new car. Versus if interest rates are very, very high, if I have to pay, say, 10% a year to borrow money to buy a car, I'm much less likely to buy that new car. Okay, so all of these factors here, these are non-income factors. These are factors other than income. Income is what? Being held constant. All of these factors actually affect consumption. In conclusion, changes in income move us along the consumption function. Changes in non-income factors like confidence, wealth, and interest rates shift the consumption function.